Hi, in this video I'm just going to briefly demonstrate how to run a regression analysis in Excel, and also how to produce an XY scatter plot. Here I have the data that's used as an example in chapter 2 of our textbook. We saw this back in the first week of class, and we've seen it I think a few times since. So I want to run a regression analysis with income as the explanatory variable and food expenditure as the dependent variable. So these are my x values, these are the y values. To run this regression analysis, I am going to use data and then the data analysis tool, which has already been added in on my computer. Then from the tools I'm going to select regression, and then this pop-up window is presented, and we need to select various things. So first we'll want to know the Y range, and that is my food expenditure values. I'm going to include food expenditure, the title, in my selection. I'm now going to click on the X input range and then select all the income values including the title. And because I included the title or headings, I have to tell Excel that, and I'm going to tick labels. Then I need to decide where the regression output will be presented. I'm going to get it to do that in this same worksheet, so I'm going to click on this field and then left click up here on this cell, and that's going to be the first cell of my regression output. There are various options down here which you could try out, but I'm not going to select any of them just in this demonstration. So I'm going to click OK, and then the regression output pops up. It's a little hard to read some of these words here, so I'm going to left click on this column and drag across and then release. And having selected all those columns, I'm then just going to go to between any of the two columns and double click, left click, and the column widths will be automatically reformatted so they fit everything in nicely, and it's a little bit easier to read. Now there's a lot of data here, but the three things that we're going to be most interested in are these two figures down here, and they are actually an estimate of the intercept, the y-intercept in the simple linear regression model, and an estimate here of the slope of the simple linear regression model. The other main parameter in the simple linear regression model is the variance of the error terms, and that is shown right here. Oftentimes people will report the standard deviations rather than variances, because the standard deviation is in the same units as the dependent variable, and this standard error up here is actually the estimated standard deviation of the error terms in the model. It's just the square root of this number, something which I can just quickly show you. I'm going to type equals to get a formula started, sqrt, which is the square root function, open a bracket, click on the error variance, the estimated error variance down here, close the bracket and enter, and you can see that these two numbers are identical, showing that this number is the square root of this number. In statistics, whenever you see this word standard error, you should interpret it as an estimated standard deviation, and this number, just to reiterate, is the estimated standard deviation of the error term in the model. Let me just quickly show you this handout. It was provided in week 4, and this is a slightly different version which I've now made available in Blackboard in the main unit content section at the very top. It's called Ordinary Least Squares Estimator Summary, and here's the assumptions of our simple linear regression model, and the parameters that we've just been looking at estimates for are this B1, the intercept, B2, the slope, and sigma squared, which is the variance of the errors. the formulas for each of those estimators are down here, and Excel has just basically done those calculations in the background on the data that we provided and given us the results. Okay, back to Excel. So that's how to perform a regression analysis. Oh, and I just might add one other thing. In week 1, there was an exercise that asked you to do something very similar to this, well, in fact, to do this identical exercise. And in Blackboard, in the week 1 section, you can get a document called week 1 exercises solutions, and in it is you'll find this worksheet. It's called food regression, and there's the output that we were just looking at with a few notes added to it to help in interpreting it. You don't need to know all of these things right now. We're going to see them over the next few weeks, but some of them we have already encountered, and I think it would be useful for you now to go and have a look at this and see what sense you can make of it. Back to our main Excel file, I'm now going to delete these columns just to clear up some space, and I want to produce a scatter plot for this data. And I'm going to do it using insert chart. There are other ways of doing it, but I would just want to show you this because inserting a chart, here we're going to do a scatter plot, but there are a whole range of other options that you can choose to produce a visual presentation of information. So it's useful to be able to know how to use this insert charts kind of tool. Okay, to insert a chart, I need to first of all select the data, both the X and Y values, which I've now done. Then I want an XY scatter plot, so I'm going to left click on this, choose that sort of like default option, and there's my scatter plot. Just bring it to the top of the page. Right, and make it a little bit bigger. Okay, now the unfortunate thing is that the insert chart interprets the first column of data as the X value and the next column as the Y value, and I have the information reversed. So what Excel is doing is plotting food expenditure, which I want to be the Y variable, on the X-axis, and income on the vertical axis. We can change that easily. I'm going to right click on any data point, then choose select data, and there's like one series of X and Y values here which Excel has called income. I want to edit that. I'm not too fussed about the series name, but I want to change these X and Y values. In fact, I want to reverse what's shown here, because at the moment the X values that are being used in the scatter plot are actually the food expenditure values, and the Y values are income. So it would be easy enough to change these. I'm just going to click on that A and change it to column B, click on that A and change it to column B, and do the opposite down here. I could have just reselected that data by clicking on it, but that's now been done. I'll click OK, I'll click OK again, and now we've got the scatter plot with the correct variables measured on the horizontal and vertical axes. So with the scatter plot, you could change the heading just by right clicking on it, or even just left clicking will do it. I can add axis titles by left clicking on this button and then clicking that, and if I just click on that Y axis title, I could change it to food. That's not very impressive. Maybe if I click up here, I can type food expenditure, and it'll change that heading. And I could do the same thing down here, but I'm not going to bother. The final thing that's worth knowing here is that I can add a regression line to this scatter plot, and to do so I need to right click on any data point, then choose this Add Trend Line option. It'll bring up these options for you, and there are various kinds of trend lines that you could pick, but we just want to produce a line, given that we're working with the simple linear regression model. So that's the default. Just scrolling down here, I'm going to ask Excel to display the equation of the line on the chart. And also, if you look at this regression line, it'd be nice if it extended back to the y-axis. At the moment, it's just going only as far as the lowest x value and only as far as the highest x value in this direction. So I can ask it to go backwards, and this lowest x value I can actually see up here is 3.69. So I'm going to ask it to go backwards by 3.69, and it'll extend back to show us what the y-intercept is. I could also get it to go forwards if I wanted to, but I'm not too fussed about that. Okay, now just here's the equation of the regression line, and if you compared this equation to the regression output which we saw earlier, you should find that this number here, 83.416, was the intercept coefficient as Excel described it, and that this 10.21 was the slope coefficient. I think Excel would have had that described as the income on the left and then the value in a column headed coefficient. And the interpretation of these is that the 83.416 is the intercept that we can see down here, and the 10.21 is the slope of this regression line. That means that for every unit by which income rises, food expenditure on average will go up by $10.21. And in fact, on this axis, we're measuring hundreds of dollars. So it's for every $100 that income goes up, household income, food expenditure will go up by $10.21 on average. Right. Well, that's a brief introduction to performing a regression analysis and drawing a scatter plot in Excel. If you have any questions about this, please post them on Blackboard.